Hello, everybody. Welcome to our talk. We'll be discussing how to build Xbox games with Unreal Engine's new GDK plugins and how these scale to more devices in the Xbox ecosystem. To get started, we'll do introductions. I'm Zach Cooper. I'm a principal product manager in the Xbox Platform Developer Organization, where I build products to help simplify building your game for Xbox with a specific focus on how Xbox functionality works great within game engines. I'm a game developer by trade as well. I've shipped 12 games across studios like Surreal Software, Monolith Productions, Turn 10 Studios, and BattleBarge. And I'll hand over to David to his introduction.
Thank you. I'm David Harvey. I'm the senior engine programmer on the console team at Epic, and I'm also the Xbox platform owner for Unreal Engine. Over my career in the games industry, I've developed for every generation of Xbox. I'll come back in a little while and talk about Fortnite, but for now, I'll hand you back to Zach.
Thanks, David. All right, our focus for this talk is really around 4 themes. We're looking at learning more about the Xbox ecosystem and our compatibility programs, really giving an up-to-date view of building for Xbox. We'll get a deeper dive into the integrations with Unreal Engine and how Microsoft GDK plugins for Unreal Engine make it simpler and streamlined to build for Xbox. David will come back up and do a walkthrough on insights from Epic Games on how they use these plugins to ship Fortnite on the Xbox PC app. And then we'll talk a little bit where we're heading in the future and with Unreal Engine 5.8 releasing yesterday as far as improvements to the plugins and workflows. First, we'll dive in on the Xbox ecosystem. Xbox can be synonymous with living room game console. That is our core, but we've continued to invest in building and bringing Xbox games across a broader range of devices and form factors than ever before. This matches trends that we've seen with player behavior, with 43% of players playing on multiple devices, especially younger generation that grew up with apps that roamed across devices and experiences that were more and more portable. When we've analyzed engagement, players that who play across multiple devices also play 2.2 times more on average with titles that support Xbox Play Anywhere, allowing them to keep their progress across platforms and devices they play on. The breadth of the Xbox ecosystem matches nicely with the range of platforms, devices, and form factors supported by multi-platform game engines like Unreal Engine, where our integrations together unlock broader reach for game developers, where the platform and engine have invested in scalability that can reduce their costs to bring their games to more players. Over the past year, we've invested in improvements to bring more players to the Windows 11 devices, providing even more reach and supporting a multitude of form factors and device types. Some key examples of this are recent support for native ARM64 games, supporting this process architecture for games that want to optimize battery life, want to optimize for CPU performance by running natively versus running via the emulation layer. We've also invested in a controller navigable and unified experience with Xbox mode, bringing your Xbox on PC games and games from other PC storefronts together through the aggregated game library, bringing a dedicated gaming experience together for Windows. Last fall, we partnered with ASUS on the launch of their ASUS ROG Xbox Ally and ROG Xbox Ally X, 2 Windows-powered handhelds that helped optimize Windows 11 for a controller navigable experience with Xbox mode. These improvements are going to be rolled out as our default experience across a broader range of Windows handhelds in the market. We want players to be able to seamlessly play their games on Windows-powered handhelds, and to achieve this, we launched the Handheld Compatibility Program, providing a range of ratings and compatibility to ensure players understand how their game will work on these devices, building with controller navigation in mind, scaling UI and text, and supporting virtual keyboards out of the box will help you achieve handheld optimized rating and badge in the Xbox PC app. Getting feedback on compatibility issues is built in as part of your Xbox PC app submission process. As we think about how the Xbox ecosystem is evolving to reach more players across more devices, we want to meet game developers where they are and provide improvements to how to build for Xbox within Unreal Engine. We'll discuss the current state of the platform support and how our new plugins help streamline building for Xbox on PC. A little bit of a history on the evolution of the PC GDK. So building for Xbox on PC existed with Unreal Engine and has since 2020 with the introduction of the Win GDK platform and Unreal Engine 4.25. This platform was aligned with the Xbox One, Xbox Series X and S platforms as a dedicated standalone platform within the engine. As games were developed for Xbox on PC using this platform, we observed developer friction around having to do duplicative compilations, cooks, and navigating challenges with third-party plugin capability. Unreal Engine plugins require you to specify what platforms are allowed to use it, and the Win GDK had been a private platform alongside Xbox One and Xbox Series X and S. It made it hard for third-party plugins to support it and more challenging for developers to understand the difference. It did cause games to ship with missing features or functionality in the Xbox PC app versus other storefronts that utilized Win64. In 2024, a new set of experimental plugins were released supporting the Win GDK platform and allowing you to build Xbox on PC. These are called the Microsoft GDK plugins for Unreal Engine. The Xbox Platform Developer Organization, in partnership with the Coalition's Xbox Games Technology Group, which just did a talk an hour ago here, started to validate these plugins in internal integrations and share feedback to Epic Games. And then in 2025, I clicked ahead too quickly. In 2025, these plugins hit beta functionality and were battle tested with Fortnite ahead of its launch on the Xbox PC app in the fall of 2025, which David will go into in great detail of the learnings there. And that brings us to today. These plugins are public and available via the Unreal Engine source on GitHub and the Epic's game launcher. So you can get started building with the GDK through those avenues. And these plugins are also battle tested with the fixes and improvements from Fortnite utilizing them, in addition to multiple first-party and third-party studios adopting them as their go-forward way to build for PC GDK. So what are these plugins and what do they do? They consist of 3 primary plugins. There's 2 game runtime plugins and 1 editor plugin. And there's a set of optional plugins that you can choose to utilize as well for your specific needs. These plugins are built off of Win64 as a platform in Unreal Engine, aligning with other stores and removing key friction with the bifurcated platform like Win GDK. They are built for enabling you to more easily build games for Xbox on PC, and their foundation of the future of building Xbox games in Unreal Engine. The first one is called the Microsoft GDK Runtime, and this is a game plugin that ships with your game. It provides interfaces for the GDK runtime to be able to leverage APIs for features like user behavior, system UI, game saves, and more. This plugin allows flexibility in how you integrate it into your existing PC game, providing capabilities to build a store-specific Win64 executable with its own build target, or build a unified executable that has runtime switches for different storefront behavior. The second is the Microsoft GDK Store plugin, which is the editor side of the workflows and does not ship new games, editor configuration only. This provides integration with the Microsoft Game Config and all of the kind of common UX flows for creating and managing that. It associates your game locally with your Partner Center configuration, making that step much easier for you to do. And then it allows for you to configure things like your store information, your logos, localization. In addition to all the upfront configuration, this is the plugin that also provides MSI XVC packaging configuration. There's simplified packaging paths that build off of your stage build. There's also advanced options for intelligent delivery to choose what to install as well. And then there's also, which David will go into more detail, advanced packaging options to configure pack alignment to reduce size deltas, which we'll be fixing in a future version of our packaging format. And the third primary plugin is the Online Subsystem GDK, which is a game plugin that ships with your game. This plugin hooks into Unreal Engine's online subsystem, providing a store-agnostic abstraction layer for common actions like sign-in, achievements, friends, presence, commerce, and more. This supports game saves for things like cross-progression as well. The Online Subsystem GDK does rely upon PlayFab. It requires a PlayFab ID to use matchmaking interfaces specifically. This can be enabled or disabled in your Project INI file, depending on your choice. Additionally, the Online Subsystem Selector GDK plugin, which is new and introduced in Unreal Engine 5.8, is an optional plugin that can help support a single executable scenario to better allow for switching between online subsystems at runtime. Now kind of digging into what I mentioned earlier around the Xbox ecosystem evolving to more devices. When building for Windows-powered handheld, working towards getting to handheld optimized, there's a set of plugins and engine features that help you achieve this easily. There's a set of game input plugins that provide easy integration for controller navigable experience. There's a virtual keyboard plugin that helps make it very easy to ensure that you still prompt to virtual keyboard on the appropriate devices for text input. And there's also a handheld detection, an engine function that determines if the game is running on a handheld, which can be used to do different runtime behavior, modify performance, basically do bespoke behavior to running on a handheld. And then can I test this use these plugins on remote devices? And we'll be actually doing a demo after this at the Xbox booth. But we shipped earlier this year a set of tools called the Xbox PC Remote Tools. And those allow for you to remotely iterate on handhelds, Windows PCs. And we've, with 5.8, integrated that directly into the project launcher. And so this helps you easily deploy, launch, debug games directly within your editor onto remote Windows devices. And it also supports Windows games broadly. It has no direct dependency on the Microsoft GDK or Xbox PC app. So in the demo, we'll just show you a default project being deployed and launched. You can use that for however you'd like to benefit your testing on these different devices that are not your main dev machine. So we talked about the Win GDK and the platform that existed kind of at the inception of PC GDK integration within the engine, and that's the dominant platform used today for building PC GDK games. So if you're using that, there's a migration script, and it's been provided in Unreal Engine 5.7. These plugins exist in 5.7 as well. The real difference between 5.7 and 5.8 is that they've moved out of beta to be fully supported, and they're publicly available. So the accessibility of it, the ability to utilize it and know that a title like Fortnite has gone through the paces and dogfooded it is really the difference between the two. But we provide a migration script that supports converting your U project to Win64, enabling the Microsoft GDK plugins for Unreal Engine, and setting up the GDK subsystems as default. This will also modify your default engine INI to add configuration options, but will not directly impact the behavior of your normal Win64 build. Now I'll hand over to David to talk more about how Epic Games use these plugins to ship Fortnite for Xbox on PC alongside the the ROG Xbox Ally launch. David?
Thank you. So yes, we were a small team. We had about 8 to 10 weeks. The main goal was to get Fortnite on the Xbox PC app, but we also wanted to get it running well on the ROG Xbox Ally as well, because we were targeting the Ally launch window. And this also coincided with a Fortnite Crew subscription being included in Xbox Game Pass Ultimate. So overall, it provided an excellent opportunity to battle test the PC GDK plugins. Before we started, it was necessary really to evaluate whether we should use Win GDK or the PC GDK plugins. As Zach said, Win GDK was added back in 4.25 and is well established. It's a distinct platform from Win64, so it needs a separate cook process. And it was originally designed to make it easier to port Xbox games to PC. It's simple and straightforward, but has got a few little issues with it that have been discovered along the way. Alternatively, we could use the new PC GDK plugins for Win64. They're fairly new, coming in 5.4, with the dedicated plugins for adding store and runtime support. And as Zach mentioned, all the other GDK plugins are now available for Win64 too. This offers more flexibility, but does come with a bit of extra complexity. Fortnite in particular had 3 choices. We could turn on the Win GDK platform for Fortnite. We've got lots of platforms already, so that's fairly easy. That would allow us to reuse the Xbox code paths quite easily as well. But as I said, Win GDK is a separate platform and would need a separate cook. We could enable the PC GDK plugins in the existing Fortnite executable. Having a single unified executable is much easier to manage, but the runtime needs to behave differently depending on whether it's launched on the Xbox PC app and then connecting to Xbox services, or the Epic Game Store and Epic Online services. So the third option would be to create a separate Win64 PC GDK Fortnite executable. This lets us reuse the Xbox code paths easily, but does come with some added complexity. And the migrate Win GDK script that Zach mentioned offers these last two options to you as part of its wizard process. So for Fortnite, or this project in particular, we had very short timescale and a mature live code base, and that pretty much ruled out having any major refactors, so we couldn't do the unified Fortnite executable. There's so many assumptions in the Fortnite code that the platform is the store, and decoupling that would be quite an effort. So either Win GDK or a dedicated Win64 PC GDK executable. Fortnite's content is huge and changes regularly, and this was the other constraint. So that ruled out using Win GDK. Having two separate cooks would add considerable build and storage overhead, whereas PC GDK is Win64, so it doesn't have this issue. So the conclusion was to use a dedicated PC GDK executable. The separate executable is done by a brand new build target file that we created. Fortnite client MSG, Microsoft Game Store. It's Win64 only, and we had new MSG ifdefs to allow easy extension of the existing Xbox ifdefs. And there's also a custom ini layer for overriding any data-driven settings that we need. The second decision that had to be made was how to manage the packaging and package generation. We could use the new MS Game Store plugin. This would allow us to reuse the existing Win64 builds pack files, and the plugin automatically generates the MSI XVC package from the stage data. The alternative would be to use the slightly older MS Game Store custom deployment handler. This offers a separate staging pass and has custom pack generation parameters, and it's what the Win GDK platform is built on top of. So the question is, can we reuse the existing Win64 pack files? Well, Unreal's pack files are aligned to 2K by default, and MSI XVC patching works on 4K blocks. And in local tests on a game of Fortnite size, we found significantly larger patch downloads if we used this option. And Fortnite size and update cadence made the trade-off unacceptable, given how frequently we update the game. Most titles are unlikely to hit the scale or cadence that Fortnite releases at, and the best approach will depend on your game and your patch cadence. It's worth noting, as Zach mentioned, that the April GDK has a preview of a new version of MSI XVC that no longer has this 4K block restriction. So a little bit more about the MS Game Store custom deployment handler. It generates 4K aligned pack files automatically, so the patching problem goes away. But it is necessary to stage and then repack the game a second time. And we enable this via an ini setting that we'll see in a minute. Our Horde build process for this project was slightly different from any of the other ones in Fortnite at the moment, because it's not an actual platform. Our normal Win64 cook generates a Zen cook snapshot, and our MSG Horde job depends on this. When it's uploaded, the build then downloads that snapshot. It stages the build with the custom deployment handler, generating our 4K aligned pack files. We then rename Fortnite client MSG to just Fortnite client. That's for graphics driver profiles and a few downstream tools that depend on executable names matching. Then Easy Anti-Cheat works its magic on the staging directory. And then finally, the MSI XVC package is generated, again by the custom deployment handler. To configure the package itself, we use GDK's intelligent delivery in place of Epic Game Store's user-facing selective install. The configuration for that was easily adapted from the Xbox configuration. Our initial release used on-demand chunks, but more recent releases have switched to user-facing features and recipes on both MSG and the Xbox builds. This allows players to manage their Save the World installation directly through the Xbox system UI. And it now brings us to parity with Epic Game Store's selective install. We were a few challenges along the way. This shared Win64 custom deployment stuff did result in a much more complicated build graph. It took quite some time to get everything just right, and it did make build graph iteration a lot more cumbersome. And even today, any PC GDK pre-flight has to trigger a full Win64 build too because of that cook dependency chain. Easy Anti-Cheat needed a couple of Microsoft Game config generator changes to override the launch executable to launch the Easy Anti-Cheat bootstrapper, and a little tweak for custom install actions. The other challenges we faced were around deployment and debugging. So deploying, at the time, we didn't have the Xbox PC remote tools, So we relied on shared folders for deploying onto the ROG Ally devices for testing. The normal local F5 debugging is easy. If you want to just run against the stage content and you're not too fussed about debugging chunk installation, then you can just override the base directory like that, pointing to the binaries directory of your game. F5 debugging a locally installed package for testing things like chunk installation is a little bit more painful. You have to build your development executable, rename it and copy it over the top of your package's launch executable, and then use either the Visual Studio app package debugger, or if you want command line modifications as well, use WD app launch with wait for attach, and then attach in Visual Studio to the running process. There's no fix for this yet, but it's not a commonly used path, and hopefully most people won't have to suffer through it. So let's take a closer look at my build target file. Here you can see I'm adding the various plugins that we needed. You'll note I'm not using the MS Game Store plugin here yet because we're using the custom deployment handler. We use a custom config file or custom config folder to load our MS Game Store specific things on. And because we're overriding the custom config, we need to use a unique build environment. We did find that some of the system UI would get stuck behind the window if we were using exclusive full screen, or sometimes not even show up at all. So the simplest solution was to disable exclusive full screen on this build. There was a presentation yesterday that said exclusive full screen isn't actually all important these days. And then finally, we attach a little bit of metadata to every crash report that we send to the Epic Crash server, so we can differentiate this build from the Epic Game Store one. Let's have a look at the Windows ini file that we use, our custom Windows ini file. So first of all, that's how you select the custom deployment for MS Game Store. That gives us our 4K alignment on pack and IO store generation. Easy Anti-Cheat needs to modify the staging directory before packaging, so we can't pre-cache it. Out of the box, we generate the layout XML from the contents of everything that was initially staged as part of the staging process. Whereas turning off pre-caching will package everything in the staging directory. If you're going to do this, be very careful to sanitize your build first in case you ship PDBs or development builds or anything like that. We override the Easy Anti-Cheat launcher. We override the launch executable to launch the Easy Anti-Cheat launcher there. That option can be used per configuration, per architecture, depending on your game. And then the Easy Anti-Cheat redistributable expects to live under the game binaries folder. So this new custom install staging route field was added there as well. We're using intelligent delivery, so we want to set the default provider to the GDK package chunk install module. And then finally, we specify that we are using the GDK online subsystem. For handheld compatibility, we use the Win Virtual Keyboard plugin. This uses core input view kind gamepad for Windows UI view management and works on both the Xbox PC app and the Epic Game Store. Unlike other virtual keyboards, it sends raw WM keydown events to emulate actual physical hardware rather than returning a string. Fortnite dynamically enables this when we're running on a handheld device. We check to see if we're on a gaming handheld. We find the Allow Virtual Keyboard CVAR, turn it to true, and then load the Win Virtual Keyboard module. The main challenges we faced getting handheld compatibility were around UI legibility and small text in some of Fortnite's custom controls. And hopefully these fixes have improved the mobile experience as well. The WM keydown mechanism did actually cause a few issues as well. Fortnite has a method to automatically switch between gamepad and keypad and mouse mode, depending on the last input that it received. But if you brought up the virtual keyboard with the gamepad and then pressed a key, the UI might sometimes reset thinking it was in keyboard and mouse mode, and sometimes it would change the focused widget and close the virtual keyboard. So that was a bit frustrating. A general case was fixed in the common input subsystem now, though, and there were a couple of Fortnite controls that needed special casing. For touch input, it's easy enough to turn on with that ini setting there. We did find that some of Fortnite's UI elements didn't properly support touch or drag. And we also discovered a strange issue with register touch window that would send an extra rogue WM mouse move message, which would also cause the same keyboard and mouse gamepad issues we saw earlier. A workaround for that made it into 5.7.2. So let's have a quick overview of the new changes that went in to support this. GDK package generation now on as custom config. That's not that important, but we've got the option to disable exclusive full screen there, override the launch executables for Microsoft Game per configuration and per architecture, and also override the custom install root directory. And then finally, the common input subsystem fixes for Windows Virtual Keyboard. And again, all of this stuff is in 5.8, publicly available, alongside support for the new Xbox PC remote deployment tools that would have made our lives so much easier. Looking to the future, potentially we could go towards having a unified Fortnite executable. For that, we'd have to replace all of those MSG and Xbox if-defs with runtime switches. We could use the new GDK online subsystem selector module instead of custom config. This would load in an extra set of ini files on top of whatever's already loaded if it finds itself running under the Xbox PC app. But the big thing would be MSI XVC2, which is in preview in the April GDK, and I believe being formally released in the October GDK of this year. This means that the 4K-aligned pack files wouldn't be necessary, and we can get rid of all of that custom deployment stuff and use the MS Game Store plugin instead. This would result in a much simpler build graph. Most likely, we could just have, at the very end of the normal Win64 build process, we just generate the MSI XVC package in the final step. So how did we do? Well, we went live on the Xbox PC app for all Windows 11 PCs in November of last year. This was 1 month after the ROG Xbox Ally launch, but we were going for the launch window, not the launch day, so that's fine. And we achieved certified handheld optimized in March of 2026. And with that, I'll hand you back to Zach to bring us home.
Thanks, David. We'll shift to look at what's coming next as far as the Microsoft GDK integrations in Unreal Engine and talk about some key takeaways. So as David mentioned, the plugin improvements in Unreal Engine 5.8 include public availability of the Microsoft GDK plugins with no work being required to reconfigure if you are already using them in Unreal Engine 5.7. Additionally, game input plugins have been updated to support the latest game input features. The online subsystem selector, as we've talked about, is available in this engine version, provides simplification for supporting a unified executable across PC storefronts. Engine improvements in Unreal Engine 5.8 include support for the April 2026 GDK, experimental support for ARM64 packaging and native ARM64 GDK libraries, and support for the Xbox PC remote tools directly integrated in the engine as part of the project launcher flows. So some key takeaways from this talk is the Xbox ecosystem spans more devices and form factors, reaching more players than ever before. Players engage more when your game supports Xbox Play Anywhere and seamlessly plays across multiple devices. The Microsoft GDK plugins for Unreal Engine are battle tested by Epic Games with the launch of Fortnite and are publicly available in Unreal Engine 5.8. These plugins are the go-forward way to build for Xbox on PC, so please leverage them to continue to get the latest features and a more streamlined development process. And lastly, building for Xbox on PC as the foundation will set you up for success as our ecosystem continues to scale in devices and form factors in the future. And with that, thank you for attending our talk and learning more about these enhancements that the Microsoft GDK plugins for Unreal Engine provide. To learn more, please read more on our link here, our AKMS. We want to hear your feedback on how we can continue to improve Xbox integrations with Unreal Engine. So please use the QR code on the next slide to give us feedback or stop by the booth and let us know. That's it. Thank you.